Good morning, Mr. Herman here with our last video in Unit 1. We're going to take a look at similarity proofs. So last year you looked at congruency proofs, which meant that we had to show that sides and angles were congruent. But this year we're going to look at similarity proofs. So we still need to use some of the same reasons, but we only have to show that angles are congruent or sides are proportional. And then we also have a couple different triangle similarity reasons rather than our congruency reasons. The main difference being that we have this angle-angle triangle similarity. So right here, this is what I'm going to call our proofs toolkit. And these are all of the reasons that we might see when we're writing a similarity proof. So we'll talk about given in a minute. But vertical angles, angle bisector, alternate interior angles, corresponding angles, and reflexive property, those were all in the 1.2 lesson that was the 1.3 lesson, as well as angle-angle similarity right here, as well as side-angle-side similarity and side-side-side similarity. 2 or 3 sides are proportional. We will not see that in this video. However, we will see that in class, and so we'll talk about that one later on. The corresponding sides of similar triangles are proportional and corresponding angles of similar triangles are congruent. That will kind of be our wrap up at the end of a proof if we're looking for proportional sides, such as fractions, or congruent angles in our triangles. Okay, so we'll talk about those when we get to them today on our proofs. So let's go ahead and get started. So we have a pair of triangles here that we are trying to show some proportional sides. I know it's proportional sides because I have fractions here. And whenever we want to show proportional sides, we always need to show similarity first. Okay, so let's visit our proof here. We've got statements and reasons. Those are going to be our 2 columns. And then we start off with BE. The symbol means parallel to CD. Notice how that's given to us. And so our reason will be given. Okay, so a reflexive property. Remember, reflexive property is an angle that's in both triangles. So in this case, we have a smaller triangle here that's in orange, and we'll have a slightly bigger triangle here in green. Okay, so we've got one angle that's in both of those, and that is angle BAE is congruent to angle CAD, because that is the same angle. It's in the small triangle and it's in the big triangle. So let's go ahead and take a look at our next couple pairs of angles. So let's go ahead and mark these. So you've got one pair of angles congruent so far. So we have ABE. Just as a reminder, this middle letter is going to be the vertex of our angles. So we have ABE. Let's mark that here in purple. Okay. Angle ACD. And so we're able to do that because we have parallel lines. What is the name of those angles? Hopefully you said that they are corresponding angles. Okay, so since it's in the top right hand corner here, the top right hand corner here, those correspond with their position. So let's take a look at our next pair of angles. So we'll pause for a second. We could stop here. We have one pair of angles congruent, one pair of angles congruent. And so we can automatically go down to angle-angle similarity now, but I do want to show you that we can show another pair of angles congruent. Okay, so let's say we have angle AEB. So there's in the middle AEB. All right, and then we have angle ADC, And why are those angles congruent? Once again, those are corresponding angles. Okay, so I'm using some abbreviations here that you can use as well. Now, why are these triangles similar? We said a pair of angles here, angles here, angles here. So we have some extras. So I'm just going to go ahead and go with angle, angle, similarity. Okay, so I've shown that we have at least two pairs of angles congruent, so I have angle, angle, similarity. Now, we're not done yet. Okay, just as a reminder, there's our squiggle. That's our similarity symbol. We wanted to prove our conclusion, AB over BC equals AE over ED. So whenever we end with proportional statements here, we're going to say that corresponding sides of similar triangles are proportional. Because we show that these are similar triangles, so we know that all pairs of corresponding sides have to be proportional. So let's go ahead and work through a couple full proofs. So in our full proofs, we always want to start with the given. So we're going to write our given in here. So our statements are GI is parallel to NT. Okay, this means parallel. And then IN intersects GT at A. And that's given. Okay. So I do want to make a note before we go on of what parallel looks like. These are parallel lines, TN or NT and GI, and so we might see arrows on them. So let's go ahead and take a look at some angles here. So we're going to say that these two angles are congruent. So I'm going to call that angle IAG is congruent to angle NAT. And why are those angles congruent? They are vertical angles. They are across from each other. So they're across, they're going to be congruent. Let's get another pair of congruent angles here. We have parallel lines. So I can find another pair of congruent angles. Now these ones are not going to be corresponding like we saw before. So we have angle G is congruent to angle T. Okay, so this line GT, that's our transversal, the line intersecting our parallel lines. So these are inside the parallel lines. What are these angles going to be congruent? They are alternate interior angles congruent. Okay, now let's go ahead and see if we have enough information to show that these triangles are similar. We have a pair of angles. I have a pair of angles. I have AA. That works for me. So we have AA similarity. And then we can say that triangle GIA is similar to triangle TNA. So once again, we use angle, angle, similarity. So let's go ahead and get down to our last proof we're going to take a look at. All right, so our given, we already have arrows on our triangles, but we're also told it that IE is parallel to VO. So let's write that down first. And that's our given. You can always start with your given. So if you're not sure what to do in a proof, just write down the given statement first, and that's going to be the reason why. Okay, always a great way to get something good on your proof. So let's go ahead and look at some congruent angles here. So we've got a small triangle here in purple. We have a big triangle here in green. So we've got an angle being shared between them. And so we have angle IDE is congruent to angle VDO. And since it's in both triangles, it has to be the reflexive property. So let's take a look now at another pair of congruent angles. We've got parallel lines. And so we have parallel lines here. We have a transversal cutting through them. So this angle is the top right corner. That's also the top right corner. So we can say that angle EID is congruent to angle OVD. They're in the same position. So those angles are going to be corresponding. So we've got an angle, another angle. So that's enough for angle-angle similarity. So angle-angle similarity. We also have to write that similarity statement of triangle, let's see, IDE is similar to triangle VDO. Notice how my parts correspond. So V is bottom left, D is up top, O is bottom right. I is bottom left, D is up top, E is bottom right. So we call those corresponding angles or corresponding points, which is important for the order. Now I'm going to finish this proof off here. Let's go and put our fractions in here. That proof part's always going to come last. ID over IV equals ED over EO. And since I have proportional sides here, I can say that corresponding sides of similar triangles, run out of room, are proportional. Okay, so since I see those sides at the end, that's what I'm going to go with. If I had angles, I could say that corresponding angles of similar triangles are congruent as well. So this is our last video in Unit 1, working with similarity in proofs. And you can go ahead and work on the assignment.